Hi, I'm Keith Rucker, and today I'm going to talk a little bit about building a wooden pattern. This is going to be for a set of pulleys that will drive the side heads on a planer matcher that I'm working on restoring. It's a J.A. Vance planer matcher that belongs to the Georgia Museum of Agriculture. We've been working on restoring this machine now for a couple of months. And in the process of doing the restoration, unfortunately, as we tried to get the old pulleys off of the two shafts that drive the two side heads, we busted the pulley. Long story there. Basically what happened was that sometime in the past, a previous person who was working on this machine, when they put the keyway in to key this excuse me, I've been getting over the flu, but when they put the keyway in to drive this pulley, they actually drove it in from the end rather than putting it in properly, and they ground that keyway in the shape of a wedge. And it was not possible to really see this as we were taking the machine apart and trying to press that arbor out. And of course, as we were pressing that arbor out, unfortunately we were pressing it in the direction that the wedge was getting larger and larger and larger. So this is the part right here. This is the original pulley. And it would actually have gone on the machine, yeah, kind of like this right here. The pulley, the belt would wrap around. This top flange just basically kept it from coming off the top because it had the belt has a half twist in it, and that just helps keep it on there. So anyway, there's an arbor running through here that was keyed. When we were pressing that out, the keyway, because of the way it was put together, was acting like a wedge, and it started putting pressure on the casting. And as we were pressing with the hydraulic press, we eventually got to the point where it just split right down the center here, and you can see here this is not good. So chalk it up for experience. We showed the wrong way to press the pulley off. We ended up with a mess. So now the challenge is we got to make a new one of these. And this is originally cast iron, and we're going to actually make a new piece out of cast iron, just like the original. To do that, I've got to have a pattern that I can send to the foundry for them to be able to cast this. And I'm going to make that pattern out of wood. We'll turn it on the lathe, and you'll see the process that I go through to do that as we go forth. But basically it'll be a split pattern, so it'll be an upper part and lower part that will go into the mold, and then they can take this out and have the void in there needed to fill this in. And you'll see there's some interesting things about this pattern, such as it's going to need a core. I'll have to have core prints built into it as we're making it. We'll have to make a core box for the core so that we'll have that hollow spot in the middle, and we'll talk about that as we move forward. So now that you kind of see what we're working on, next we'll talk about building this wooden pattern. Okay, the first thing we're going to talk about is the choice of wood that we're going to use for this project. Now, pattern makers historically used a lot of different kinds of wood depending on the application that they were making. You probably have heard or read a lot about using mahogany. Mahogany was a favorite wood of pattern makers. They liked mahogany because it was very easy to work, but yet it was also very stable. It did not move a lot. And as we all know with wood, when you have differences in temperature, differences in humidity, that wood will actually move and change, and mahogany is very stable. Cherry was also another favorite wood of pattern makers. But pattern makers also used some pine pretty commonly in pattern making. And again, it just kind of depends on the application at hand and how that pattern is going to be used. Now, if it's a pattern that you're going to use over and over and over again, it's going to go into production, or it's a master pattern that you're going to actually cast a pattern to actually use in the foundry for doing production work, you really want to have something that's going to hold up very well. And that's a good application for the mahoganies and the cherries and things like that. In this application that I'm working in, we're going to make this pattern. We're going to send it to the foundry. They're going to make two of these pulleys. We're actually going to make two of them, one for each of the two side heads. And then that'll probably be the only time it's ever used. Unless we just ever come up with another time that this exact same pulley, we need it again for another job, which is rather unlikely. So there's really not a need to spend the time and money to go out and use a high dollar wood such as mahogany or cherry on this project. So I'm just going to use pine. But I am very picky about the pine that I'm using. I'm holding here a piece of wood that I'm actually going to use, and this is some clear pine. This is some pine. It's a little bit more expensive than just regular lumberyard pine. I was actually able to get this at Lowe's. It's expensive. It's probably, if you were needing a lot of this, you'd probably go to a lumber yard and get it a little bit cheaper, but still, for just a couple of pieces that I need here, I just ran the local Lowe's store. We picked this up. This is a very clear pine. There's absolutely no knots and no defects in this wood at all. And that's going to be very important as we move forward in this project, particularly when we start turning this on the lathe. We really want to be able to get a good smooth finish on this. Now, this pulley is about 5.5 inches in diameter. The finished pulley will be. So because of the diameter of it, I'm going to do something a little bit different. I'm going to actually glue up a segmented piece to make this out of. So if you think of this piece of board, I'm basically going to cut a bunch of different wedges out of this, and I'm going to position those, put them back together. It'll be 60 degrees in each wedge. There'll be 6 of them that go around in a circle. And the point that I'm trying to get to here is that for this pattern, because of the precision that I want, and also to help with the shrinkage and to help with just making sure that piece of wood stays stable long enough for me to get this pattern out, I want to do all of my turning so that it's on this long edge. I really want to minimize the end grain that's going to be in this. So if I were to take just a regular block of wood, you know, just say 6 inches square, and put it up on there, you're going to have a good bit of end grain as it comes around here. But by turning up a segmented piece, I will always have this long grain on the edge of my turning, of my pattern, which is really what I want. So we're going to set the table saw up now. We're going to cut out these parts so that we can get the segments, and then we're going to start gluing those up. This takes a little bit of time, but it is going that little bit extra mile to make sure that we have a good quality pattern that's going to hold up well, even though it's only going to be used one time. We want to make this thing right. So first thing I'm going to do is I'm going to rip this board. This is just a 3/4 inch by 4 inches, a 1x4 basically. Because my pattern is about 5.5 inches in diameter, I really want to have about a 6-inch diameter blank to work with. So half of that's going to be 3 inches across. So we'll rip this to 3 inches, and then we'll set it up to start cutting the segments. Okay, just to make sure everybody's clear on what we're talking about as far as turning segments here, I wanted to kind of go ahead and skip ahead a little bit excuse me, and show you what I'm talking about with the segment. So what I'm going to do is we're actually going to cut out a bunch of these these pieces right here, and basically have these discs, and we will glue these together on top of one another and build up a piece of wood that they will then put on the lathe and turn into a cylinder. So again, if you look at this and imagine the circle in there, these are not glued together yet. These are just some pieces that I've cut out. But as that circle is cutting around there, you will have this long grain, this non, actually that one's in there wrong, but you'll have the long grain and no end grain anywhere along the outside edge of this turning. So this is what's commonly called turning segments. Pattern makers did this a lot. A lot of woodworkers today making turning vessels and various types of decorative pieces actually will do segmented turnings. Not so much to get that end grain, but a lot of times they'll alternate colors of wood and different types of wood to get interesting patterns. But in our case, we're not interested in making something that's going to be a piece of work, a piece of beauty that's going to be put on the shelf, but we want it to be functional, and having that long grain all the way around there is what we're after. So we'll be setting the table saw up. Again, this is 6 inches across, so that we'll have a 6-inch circle when we put that on the lathe. We need about 5.5 inches in diameter maximum, so that gives us a little bit of extra wood to work with. So because if you think of this, your grain's running this way in your piece of wood, so just like this right here. So it's 6 inches across. Half of that will be 3 inches, which is why we ripped our board to 3 inches wide. And then we'll come in here and we'll set up our cuts. Because it's 6 pieces, this angle is 60 degrees right here. But when we're cutting this, we're going to be cutting half of that. So we'll set up our miter gauge to a 30-degree angle, and then just basically cut these little triangles out. Okay, I'm getting ready to set up my angle, and again, I want to set that up to a 30-degree angle on the compound or on the miter gauge. But I never trust the actual miter gauge, the readings on there. It'll give you something that'll get you close, but most of them I found to be pretty inaccurate. So I've actually got this Starrett protractor head. This is something that I use in my machine shop work a good bit. However, I have to admit, this is one of the most useful woodworking tools that I own, is this Starrett protractor head. It actually comes in a set where you have the protractor head, you have just a regular 90-degree square, and you also have a V-block that can be used for finding the center of a piece of round stock. So all in all, I find this very useful. So anyway, I've got this set to 60 degrees, and I'm just going to come down here now to my miter gauge, and I'm going to put this on here. And I'm just using the fence as a reference here to set this parallel to. We're going to assume that this fence is square, and I know for a fact that it is because I've checked it out. But as you can see, I've got this set on 60 degrees or as close as I can. This little knob on my miter gauge, or this little readout on my miter gauge is flopping around, literally. It's moving around, so I'm never going to get an accurate measurement there. And then I'm just going to adjust this and put this up against the fence until I get that angle just right, and then I'll lock my miter gauge down. So now I know without a shadow of a doubt, no matter what the reading says on here, this is actually looking like about 55 degrees according to the gauge, the best I can tell. But I know that it's set to 60 degrees because I'm using this protractor head to set this up. Okay, next, okay, for setup purposes now, I've got a block of wood here. This is just a short piece that I'm going to use for, again, for setting up. And I'm just going to go ahead and zip this off, make sure I've got a good 60-degree angle on here. Here our train. I'm out at the museum today, and you can hear the train in the background just going by. Okay, so I've got that angle set. This is a 30-degree angle cut on here. And what I want to do is I just want to set this up to cut out a bunch of those triangles, kind of in rapid order. So I'm just going to cut that angle and then flip the piece over and set it so that it cuts the next angle. I'm going to set my fence up over here with a block of wood to use as a stop, and we'll just tell you what I think I'll do is, okay, so using my protractor gauge, excuse me, okay, so alright, so I have set up my protractor here to 60 degrees, and I'm just going to mark down here on this, go to this corner right down here, and I'm going to mark that up through here. So I have a line now that I can use to kind of set the width of my cut. And we're just going to set it so that we cut right to that line and end up with this triangle. Alright, so I got it in there. I need a little bit extra width here on my fence. That is going to be pretty darn close. Okay, and I just got a piece of 2x4 using here as a block. I'm going to slide this back to about right here, and I'll take a clamp. And we'll clamp this to the table. Okay, so now I'm set up where I can make a cut, flip my board over, make another cut, flip the board over, and just continue doing that and cut these out in rapid succession. Okay, I have cut out my first set of segments here, and I've just kind of put them together, and I've quickly noticed a little small problem. Evidently, I didn't have my miter gauges set absolutely perfect, or it may have just been the way it was cutting, if it was moving a little bit as it was going down that miter. But regardless of how it happened, if you look at this, you see this gap opening up in the middle here when I just put the pieces together. So my angles are not just perfect. And you say, well, why does that matter? Well, I really want a good, tight fit of these pieces when we put them all together. So we're going to have to back up here a little bit and fix that problem to get our angles just exactly right. And the tool we're going to use to fix this problem with is a miter trimmer, or a universal trimmer as it's correctly called. My universal trimmer that I have is made by American Machinery Company. This was made in the late 1800s. This is one of the very first models of this particular type. This is a, let's see, this is a #1 trimmer. It says on the back universal. So this is a #1 universal trimmer made by American Machinery Company. It was made, I think, around 1897, if I remember correctly from my serial number on here. The interesting thing about this miter trimmer is this miter trimmer was actually built by Oliver, if you really think about it, because before Oliver, of course, of woodworking machinery fame, became Oliver, the name of their company was American Machinery Company. And then in the late 1800s, they got into a nasty lawsuit with American Woodworking Machinery over trademark infringements, and American Machinery Company lost out, and that is when Oliver renamed his company Oliver. So this is actually an Oliver miter trimmer, but it actually predates the Oliver name. So anyway, let me get a little history on the miter trimmer here. Basically what I've done is again used my protractor head, my stirrup protractor head. I've got this set to 60 degrees. I've gone in here and just by putting the straight edge across the two knives here, which are grounded the same thickness, and using the fence here, I've got this set to exactly 60 degrees. So I have a 60-degree angle in here. So once that is done, I will take my little blocks of wood, and I'm going to put them in here so that my long edge, the edge that's going to be the outside arc, this will be the inside of the segment. This will be the outside. I'm going to set it in here just like this right here. And basically, what I've noticed is that these edges, these outside top edges, just need to be trimmed off ever so slightly on each one. So I'll put those in there. I'll bring my knife up so that I'm just taking a sliver of a cut. I put my block in there, slide it up so that I'm just catching the edge of that, and I'll trim that edge up. And I'll do that on each of the blocks of wood. Okay, and now after going through that exercise on the miter trimmer, or the universal trimmer, you can see I've got a much tighter fitting circle now. And these are now ready to go over and be glued up. Okay, as we're moving forward here, you can see some of the segments I have here. These have been trimmed up on the miter trimmer. They're pretty much ready to start gluing up. But before I did that, I just kind of wanted to show you the game plan again here. So each one of these little segment discs, we're going to glue them together first on the edges just to kind of hold them in place. And then once we get these little discs built, we're going to start stacking them on top of one another and rotating them every other one. This way our edges will never line up, and the strength from gluing this together is not going to be based on gluing that end grain together, which is usually a very weak joint with wood glue, but instead it's going to be from gluing from face to face. We are going to glue them together on the end grain, but that's just kind of hold them in place to keep them all held together good and tight, so that we don't have big gaps in these pieces right here. Now, this is one thing that's going to complicate this particular project ever so slightly, and that is that as we move forward, we're going to design this pattern that we're going to build as a split pattern. And as a split pattern, what I mean is it's going to be two different pieces. So imagine, stacking all these together, turning it, having a cylinder, or having that piece in there. We want it to be able to part in two different pieces and actually come together. And the reason for that is in the molding process. They can put it into the mold, and they can put the bottom piece in, ram the mold up, flip it over, put the top piece on, and then ram up the rest of the mold. It's just going to make it easier on the molder at the foundry to do that. As we're building this pattern, I'm actually going to instead of making the cylinders, we're going to actually make the two halves of the cylinder. So on half of my pieces can be glued up just like this, but on the other half, we're actually going to have these pieces split in half, so that it'll come together and have a flat bottom on there. It's just going to make it easier for us as we move forward. We won't have to worry about trying to cut this whole cylinder in half, which could be done like on a bandsaw or something, but this is going to be just a much better way of getting around it. A little bit extra work involved though. Okay, so now we're ready to start gluing these up. I've got a set that have all been, the edges have been trimmed. It fits together nicely. On some of these I even went and did a little sanding on those edges just to get, so I have real good fits, and these are kind of put together in sets now that I can start gluing up. So again, because this is going to be a split pattern, I'm really only going to glue together two halves of these. But to clamp them together, the way I'm going to clamp them, it needs to go together. It needs to all go together as one piece. So we're only going to be gluing three pieces together and three pieces together, and leaving that edge there undone. So we'll just take the first piece here. I'm just using Elmer's white glue. Just a little bit about glue real quickly. Most people probably know this, but most of your yellow woodworking gold, it's just PVA, polyvinyl acetate, I think is the chemical name for it. Some of it has some additives in it that make it waterproof or whatever. But when you really get down to it, most of this glue is glue. Unless you've got a specific application where you need for it to be waterproof if it's going to be outside. The interesting thing about yellow carpenter's glue though is that yellow carpenter's glue actually has some additives put into it that will make it dry faster. If you think about it, it's called carpenter's glue. So you think of what a carpenter does. It's more of a rough construction type situation. And with those additives in there, it's going to dry up faster and actually get that held together pretty quickly. A lot of times though in woodworking or in pattern making, I really don't want my glue to dry real fast. I don't want it to dry in 5 minutes so that your set is set in 5 minutes. I really would like to have a little more open time in there. And the nice thing about just regular old white glue is that it actually has a little bit longer open time than most of your carpenter's wood glue. The other thing I like about just white Elmer's glue is that particularly on woodworking, if I'm building furniture or something like that, this particular application as a pattern probably doesn't make as much difference. But the yellow wood glue actually will dry yellow, whereas this white glue dries clear. So if you do get a little bit of a wood or the glue joint showing or something, with white glue it just blends into the project a little bit better, whereas with yellow glue sometimes you'll see something. So anyway, there's a little bit of something on glue. In this project, quite honestly, it probably really doesn't matter that much, but that's the reason I'm using this white glue. It's my favorite type of wood glue to use in pretty much most woodworking applications. So I'm just going to put a little glue on the edge. I'll take a acid brush here, just kind of spread that over. Again, I'm not going to glue this edge, and then I'll grab the next piece and just continue. I like putting the glue on both edges. To me, that just makes sure you're getting a good coverage, and when you put that glue together, it just binds together a little bit better than if you just put it on one edge. Okay, so there's half of the disc put together, and then we'll do the other half. Okay, now, because again, I want to make sure I have two different halves of this project, I've just got some little pieces of wax paper cut here, and I'm just dropping one of these in there. Really the only place the glue is going to come is right there in the apex, or in the very center. So I got this together now. I'm just going to kind of put it together with my hands, but I want to put a clamp on here to clamp this, and it doesn't need a lot of pressure, so all I'm going to use is just a rubber band. So we'll just put that on there, let that snap in place, and again, just kind of run my fingers through here to make sure everything is good, and that's ready to go and dry. Again, because we're going to be clamping these side on top of one, sandwiching all these discs together, the real holding pattern is going to be on the face of these, holding them together, but this glue in here is just going to be kind of something just to hold it in place until we get everything glued up. And then I'll just take all these discs and put them off to the side and let them dry. Okay, we have the first half of our segments all glued up now. I've just got them sitting over here, again on some wax paper just to make sure they don't stick to the table. And we're going to let these sit here and dry for a couple of hours just to make sure that they'll hold together, and we'll start gluing them up. And while we're working on that, now we've got to make the other half, and again these will have the two pieces in there that will be rotated ever so slightly, and because of that we have to cut some special pieces on the table saw to make sure everything is set up properly for that. Okay, I have this next operation set up. So basically what I'm doing is I'm making these little half triangles. So this is a 30, 60, 90 triangle rather than just a 60-degree isosceles triangle. So basically I'm cutting the same angle just like I was before, but then I'm going over to a chop saw, cutting it off square, and then going back to my table saw, cutting the angle just back and forth, back and forth, back and forth. I've got everything set up. I've test fitted a couple of pieces together. Everything seems to be looking pretty good. So we're getting to work here and show you how this works. Okay, I've got my little half segments cut out now on the table saw and got them all ready here to start assembling and gluing up. And very similar to before, you know, like we said, on these we want to rotate them about 60 degrees each layer. But because this is a split pattern, you can see I want this these pieces, every other piece, to be kind of where we have this piece here split, and this will actually be two halves, just same as before. That we'll glue these halves on top of one another here to make the blank that we'll later put on the lathe and turn out. So you kind of see what I'm after here now, and we'll start gluing these up. Same as before, just put a little bit of glue on there. Okay, we've let these little segment discs dry overnight, so glue should be good and dry on these. And the next step is I want to make sure that the faces on these pieces are perfectly flat. So we've got a little bit of roughness on here, a little bit of glue that has come out. We've got just a little bit of the kerf or the sawdust on here, I guess, from where we cut it with the blade. So we just want to smooth those up. So to do that, I'm just going to use the table of the unisaw here, which is pretty flat, and I'm going to take a couple of sheets of 60 grit sandpaper, and we're just going to glue these down. And to do that, I'm just going to use some 3M Super 77 adhesive. You can get this at any supply place around. It's a real good adhesive for putting sandpaper down on a metal surface like this. So we'll just take it and put a good coat on the back side there, and just stick this right down to the table. I like putting the adhesive on the sandpaper, not on the table, just to keep the excess around the edges from being sticky. That'll just get covered up with sawdust when you start doing this. If it was a sanding disc, a lot of times they recommend to spray both surfaces and put it together, but again, I really don't want to have that overspray here. So, and this is just going to be used for just a few minutes, so we'll pull it up and clean that up and move on. And just to give me plenty of work in there, I'm going to put two sheets side by side, just butt them up to one another. Okay, so now these are the disc. Take my fancy clamp there off, and there's a little piece of wax paper that was in between them, and we'll just take these and clean them up. And it doesn't take a whole lot. now that I've got all of my pieces sanded on the end, I wanted to just kind of do a quick dry fit here just to make sure everything was going to work out right. So basically what I did was I took half of my pieces, half of the pieces like this and half the pieces like this, and I separated them so I have exactly half and half, because I'm going to be making 2 of these. I need to be the same length. And I just put them on end to end just to check out the length, and just to kind of get an idea of what we're looking at here. Again, here's our pulley. Our pulley is about 5 3/4 inches long. I'm going to have a core prints in this, and again we'll talk about it a little bit later, but this will be for the holes that go in here. If you look, this is hollow on the inside of this pulley right here. And so I actually have to make a core to go in here to make that hollow. And again, we'll talk about that a little bit later. So that print's going to have to come out about 2 inches on this side and about 2 inches on the back side here, because we have the hole that goes all the way through, and I want to actually cast that hole into the piece. So I need my print to stick out about 2 inches on that side. And additionally, I'm going to need some work on this to hold it into the lathe, so I need about another 2 inches. So basically I need to add 4 inches in length to this. Again, we're 5 3/4 inches, we'll just call it 6 inches just to round it off. Add 4 inches on each side, that'll be 8 inches, so that'll be 14 inches altogether. And when I check this out, I'm at about 14 1/4, so I'm good. Everything's good to go there. So this is pretty much ready to start gluing up. So we'll just get started. I'm going to pick these up, move them over, and we'll start on the end and work our way back, work our way across. All right, we can leave this dry and set up now overnight. And this is one down and have one more to go. So we'll put together another one just exactly like this. Well, these are all glued up now. I've got both sets, both the top and the bottom. We're going to just let these sit in the clamps at least overnight, let it dry real good, and hopefully here next time we get together we'll show you how to put these together so they'll stay together while they're turning, and we'll go ahead and we'll actually turn the split pattern out on the wood lathe. So we'll see you next time.